Introduction. Lou Gruenfeld, if that pronounced it right. We'll be talking about the SR-71. He's a commercial pilot, but he says he's never done anything with it. But once a pilot, always a pilot. So, Lou, come on up. Lee, I'm sorry, Lee.
Morning, everybody. Thanks for showing up. I want to start with a question. When you're all aviators, almost everybody, when you think about big, exotic, beautiful airplanes, are there any particular ones that come to mind? Anybody have a favorite or?
P-51.
P-51 Mustang. Oh, good plane. Tuskegee Airmen, World War II. P-38, Lightning. Oh, yeah. I saw one of those do a ground loop at the Reno Air Show once. That was interesting. Anybody else? F-104, designed by Kelly Johnson. First plane. Okay. Huh? DC-8, big exotic plane. You need to get out more, buddy. Yes, sir. Huh? Oh, the Voodoo. Okay. Yeah. P-58. P-58. Okay. Anybody else? Okay.
Right here.
Go ahead. Huh? F1, boy, you guys go way back. I'm talking big and exotic here. But that's good. Well, I'll tell you, huh? F-105.
Full century.
All right, those are some good planes. Oh yeah, that's a real beauty. The plane you can shoot in half and it still flies. Yeah.
B-17.
17. Okay. Well, let me tell you what came to my mind. First of all, XD-78 Valkyrie. Only two built, and one of them got cracked up in a photo op. They were flying in formation with some other planes. So that's a beautiful, beautiful plane. Spirit Bomber. This to me is gorgeous, and also it doesn't necessarily have to be military because I think this beautiful plane's ever been. The Concorde is quite a story there. But for me, it's this sucker right here.
Just a technical point, you're moving that mic away from your face and we hear half of your sentence and then it disappears.
Trust me, that's all that's worth hearing. Okay, got it. Thank you very much. I appreciate that. So this is, for me, is the SR-71 is the one that I think is just fantastic plane. Okay. And the reasonable question is, what qualifies me to talk about this airplane? And the answer is not very much at all. This is not a shameless plug for one of my books. But I was so in love with this plane, I decided to write a novel about it. And it turns out, I didn't even mention the plane in this book because it turned out to be about something else altogether. However, I did an awful lot of research, and now I get to share it in a room full of enthusiastic aviators, which is really kind of cool. So let me start off. I'm doing my best here. So, let me start off and talk about some myths and facts about this plane. I'm just curious who among you thinks that these are myths or facts. One of them, which is a legendary myth or fact, is that when this plane is fully fueled on the ramp, it leaks fuel from underneath all the wings. Anybody think that's true? Is that real?
Yep.
You guys think it's real? Okay. After it takes off and gets to 25,000 feet, it needs to get refueled right away. True?
Yep.
True? Okay. This plane was first flew in 1964. Does it still hold a record for the world's fastest production plane? Okay. How about altitude record? You think so? Okay. And it grows 4 inches in length at high speed, much like myself. All right. So what we're going to do is going to talk about these, and the best jumping off place to talk about this plane is actually about it leaking fuel, because talking about that gets you into all sorts of things about the plane. So, yes, it's true. This is a picture of an SR-71 on the ground and fueled. When I say fully fueled, it's half fuel because it can't take off with a full fuel load. Full fuel load. So you see those drip points where the arrows are underneath the plane. And why is it leaking fuel on the ramp? It all has to do with this fact, which gets us into a lot. This is, in fact, the fastest production plane ever built. You're absolutely correct, and it still holds the record for that. However, a couple of things about that speed. It cruises at Mach 3.2 in normal operation, And one time over Libya, pilot was being chased by a Libyan missile, or he thought he was, because missiles can't catch this thing. And he gunned it and got it up to 3.5, which is almost 2,700 miles an hour. So this is a very, very fast airplane. Okay, LA to Washington, a little over an hour. That's not theoretical. They did that flight. And by the way, if you try to turn this thing around at high speed, it's a 100-mile radius. Now, here's the interesting thing about flying a plane that fast in the atmosphere. This is a temperature map of the various surfaces on the plane. It averages about 570 degrees, and you'll notice that the left rudder in the front of that, it gets up to over 1,000. The middle of the engine, 950 degrees. This plane flies very, very hot. What does that mean? Well, you got a little problem because there's no fuel bladder, tank bladder that can possibly stand that kind of heat. It'll just dissolve or burn up. So you can't put a bladder in this thing. The other thing also is that the plane really does expand. And so it consists of various panels, and there are spaces between the panels, like on a sidewalk or a railroad track, the old style railroad track, to allow for expansion. And then when the plane gets hot and everything expands, it seals up those joints, but you can't do that on the ground, which is why it drips fuel. And the plane does increase 4 inches in length. Even though titanium has a low coefficient of increase, it still gets hot enough to grow an additional 4 inches. So the plane is only happy when it's really high, really fast, and really high. A lot of people think that that business of a dripping fuel is a myth. So I found this in the SR-71 manual. This is the allowable drip chart. And it tells you for every point in the plane where fuel is coming out, what's the allowable, you'll see like a tail cone, 10 drops a minute, any more than that, that's not allowed. So these are all the limits for the dripping. You might ask, what happens if it exceeds the limit? Well, a bunch of guys out with putty knives, and they've got this stuff that they put over the holes, over the seams, and it burns off as soon as the plane gets to altitude, but it stops it from exceeding these drip rates. However, the fact that it has to be refueled at 25,000 feet has nothing to do with the amount of fuel coming out. It's only a couple of gallons, and the thing holds 80,000 pounds of fuel. It's because the plane is too heavy to take off. They don't have enough room in the wheel wells for double trucks and things like that. So they only half fill it or 1/3 fill it, get it up to 25,000 feet, hook up with the KC-135, and fill up the plane. That's a specially modified KC-135. So a little bit about the history of this plane. Anybody recognize this guy? Let's go. Well, Kelly Johnson, you mentioned the 104. He designed that plane. He's a legend at the Lockheed Skunk Works at Lawndale. So the CIA came to him in the middle of the 50s and they said, hey, Kelly, we need a plane so high that nothing can shoot it down. Said, sure, no problem. Came up with the U-2. Shot it down. It turns out it's not that big a deal to make a missile that goes up to 70,000 feet where this plane flew. There was just no reason to do it. So as soon as the U-2 started flying, the Soviets said, well, let's add a couple of fuel tanks to the missiles and we can shoot the plane down, which they did. So the CIA went back to Kelly Johnson and they said, hey, Kelly, we need a plane that flies so high and so fast, nothing can touch it. He went back to the drawing board and he came up with an A-12. This is a single-seat plane that first flew in 1962. They even made an interceptor, or tried to. This thing carried some missiles, wasn't very good, and it was never really deployed. They did build one. They also built a drone that sat on top of the A-12, the D-21 drone. Not the most well-conceived aviation invention in the world. The idea was the SR-71 would penetrate enemy airspace, but it had to turn around because of its range. It would launch the drone would fly over the enemy airspace, take some pictures, drop a film canister, because there was nothing digital in those days, no transmission, and then blow itself up. Very expensive way to take photos. Both of them? Oh, okay. Oh, good, good. Yeah, I've seen the drone. I've got a picture of that live, but that's really something to see. Anyway, it didn't work very well. And the other thing is, where are you supposed to put this canister in enemy territory? And when you're flying around at these speeds and at those altitudes, how are you going to drop it with any precision? So this was never really used. But the important one is this one. This is the SR-71. The gorgeous plane it first flew in 1964. And this is a quote from Kelly Johnson. And as we'll talk about some innovations, you'll see that this is really true. They had to invent everything, pretty much everything. Okay, so this is the first, this surprised me. This is the first plane built from titanium. And titanium. What? So made from titanium and has really good heat properties. It doesn't deform in the heat. It carries heat very well. But the interesting thing about making it from titanium, when this thing was designed to fly over the Soviet Union, is that all the titanium built that was used to build it came from the Soviet Union. They would have countries that were friendly to the Soviet Union buy the titanium, sell it to another country that was kind of a little bit removed, and eventually 6 countries later it came to the United States, which the Soviets never found out about. But without their titanium, there's no. Also, this is one of the first, maybe the first plane to ever incorporate some stealth technology. Full stealth didn't happen until the F-117 Nighthawk, which is sitting in the Palm Springs Museum. That was the first true one. But this had a couple of things. Sharp edges, inward tilting rudders like that, radar absorbing paint, and most interestingly, something called chine. Chines are those sharp edges, and the sharp edges contribute to its stealth capabilities. And so it reduced the radar cross-section. Now, I don't know how much you know about stealth, but a Russian mathematician in the early part of the 20th century, a guy named Barymatsov, figured out that you can configure a plane in a certain way that reduces the radar cross-section to about the size of a sparrow. And what was interesting was it didn't matter how big the plane was. It was always the same radar cross-section. And the Soviets didn't do much with it, but the Americans did. So this reduced the cross-section, and the chine itself is a lifting body, unlike in a lot of planes, like commercial planes that are just, we're talking about parasitic drag. This thing was actually like a wing underneath the bottom. And it generated these big vortices that increased ground effect so that the plane could land a little slower, because this is a really fast plane and it has the glide trajectory of an anvil. This is what powers. This is a 50,000 horsepower JT58 engine from Pratt & Whitney, heavily modified. I'll talk about those pipes there in a second. It operates in 2 modes. It's a conventional afterburner, a regular old turbojet, until it gets to about Mach 2. And then all of a sudden, they go into something else. They take bleed air from the early impeller stages. Show you. Route it through, you see those 3 pipes? There's 3 on the other side. It takes the bleed air and injects it directly into the afterburner flame, which really boosts the power. It is not a turbo ramjet. You'll hear it referred to as a turbo ramjet a lot. There's no ram air involved in this whole engine. Oh, and the other thing is, you guys, I heard guys mention some fighters you might have flown. Anybody flown planes with an afterburner? See a lot of nods. Okay, so I don't know if this is true for the planes you flew, but I know that in the F-15, every time you lit the afterburner, a little clock started. And when you got to an accumulated total of 15 minutes of afterburner, you got to take apart the engine, tear it down, and rebuild it, because it's that destructive. This thing is always in afterburner mode. That's its normal mode of operation. And it's the only engine that can do that. By the way, if you have any questions or anything, just yell them out. I don't need to stand up here and lecture. But I'll tell you, I don't know anything that isn't this presentation. So this is everything I know. Okay, it also used a special fuel called JP7 that was developed specifically for this plane. There was a problem with JP4 and then JP5, and that is that its flash point was about 450 degrees, which is about half the temperature of the skin. So if they tried to use JP5, it would just ignite right inside the plane. So this stuff I mean, when it's lying on the ground, you could throw a match into it. It's not going to burn. It's very, very low volatility, high flash point. And it needs a special chemical called triethylene butylene or something like that, TEB, which burns at extremely high temperature upon exposure to the air. So that's the only way to light the plane. It also cooled the plane. It was very important for that, although they had to put in additives to stop it from freezing at 85,000 feet. And I don't know if this was just a happy coincidence, but from the stealth point of view, the gases are hard to detect. Now, we got to talk about how to manage shock waves when you're going at 3.2. This is the exhaust shock wave, which is not that tough to manage. You got a couple of problems. You notice those spike inlets, and you've seen those on some airplanes. These are a little unique. They move in and out a little over 2 feet. They can be moved by the pilots. Conventional turbojet engines can't take supersonic air coming in. It'll just choke the engine. So you've got to slow it down. And those spikes slow it down. But an interesting thing happened when they tested it. A great big shock wave, powerful one, developed behind the spike, inside the cowling. And they didn't know how to solve this problem. And a very clever engineer named David Campbell at Skunkworks said, why try to get rid of it? Why don't we use it to limit the airflow coming in? So that turned out to work, but to control that, they have to move this spike in and out to make sure that that shock wave stays in exactly the right place, which is not easy. These pilots are not doing a lot of sightseeing, by the way. Managing this engine is a full-time job. It's really, really hard. And once in a while, that shock wave inside would blow out the front of the engine. And now you got supersonic ram air coming in, can't be done, can't do anything with it, shuts down, or what's called an unstart for technical reasons. And what happens is, when the engine shuts down, you used to have this engine generating 32,000 pounds of thrust behind it. Now, not only is it not generating thrust, it's this gigantic bunch of parasitic drag, this obstacle. So you got that thing on one side, you got an engine producing full thrust on the other side, the plane tries to yaw, which at Mach 3.2 is not a good thing. So in order to deal with an unstart, you got about 2 seconds to unstart the other engine. And there's a computer on board that detects an unstart and then will shut down the other engine. And once in a while, it actually worked. So if the pilot wasn't right on top of it, there was a problem. And then you have to extend the spike to subsonic mode to be able to restart the thing. And in order to do that, while it's spinning, you got to throw that TEB starter packet inside the engine to get the fire going. So these guys are really kind of busy when this happens, and it was a fairly common occurrence. Now, this is a guy named Bill Weaver. Notice how he's dressed, like an astronaut. So they compressed the cabin to about 26,000 feet. But the reason that they dressed him like this is in case something goes wrong. So Weaver's flying around at 78,000 feet in 1966, and he gets an unstart. Computer doesn't work. Plane starts to yaw violently. And by the time he realizes what's going on, the plane starts to disintegrate. And of course, it rapidly decelerates because of all that drag. And he says he never touched the ejection handle. The plane simply disintegrated around him. And his RSO in the back, reconnaissance system officer, he also had the plane disintegrate around him. So this suit, which is pressurized at 78,000 feet where there's hardly any air, starts to swell like a balloon. And this is the problem astronauts had when they were doing work outside on the space station, is that it gets so stiff you can't even move your fingers, you can't move anything. So he's floating around at 78,000 feet, can't get his hand around his D-ring to deploy the parachute, and just sat there praying that it would deploy automatically the way it was supposed to, which it did. And he looked about a quarter of a mile away, saw his RSO floating down, and saw the pile of burning junk below them on the desert floor, and survived. And talk about the right stuff. 3 weeks later, this guy was back flying another SR-71. Quite a guy. And in case you're interested in what it looks like punching out at 78, that's it. It's kind of like what it looks like from a spacecraft. You know, you're way above the clouds, it's dark outside. Then these are what the rear shock waves look like, and those are just controlled by little door panels on the outside cowling of the engine, just to make sure that they don't bunch up and climb back into the engine. Okay, we talked about the altitude record. Who thinks this thing holds the record for altitude? It cruises at 85,000 feet. It's gotten up to 89. No. The record is held by a Soviet-era MiG-25 Foxbat. It got up to 123,000 feet. Now, it wasn't flying up there. It did one of those, you know, drop the nose, get up to tremendous speed, crank the afterburners, head up straight up, and that's how high it got. Record for an air-breathing airplane. However, for sustained horizontal flight, this thing still holds the altitude record, and it can cruise at 85,000. Where's Gary? Gary Ludis. Gary sent me a video, a great, very funny story about an SR-71 flying over Denver Center, and he heard a Cessna pilot say, "Hey, give us our speed over the ground." And Center came back and said, "You're 90 knots." And then a Beach Baron came on and said, "Hey, what's our ground speed?" And he said something like, I don't know, 230 knots. F-16 pilot came on, 540. The SR-71 wise guy said, "Hey, what's our ground speed?" And he said, "Well, let's see, it's 1,980 miles an hour over the ground." And the SR-71 pilot came back and said, "We're showing more like 2,000. And the controller said, "Yeah, it looks like about 2,000. And those other planes were never heard from again. So sustained horizontal flight, this is, okay, as far as the cockpit is concerned, I was at Edwards Air Force Base once, and I asked an officer if I could look inside. He said, "Sure, no problem." Brought over a ladder, great big piece of cardboard, some duct tape, climbed up for a few minutes, came down and said, "Go have a look." So I go inside, and of course, the entire cockpit is covered with cardboard because it was classified. But it has since been declassified, and this is what the pilot's cockpit looks like. A busy little place. I have an overhead view too. And I'm looking around at this thing, and I happen to notice this Mach meter over here. And these guys got a little ambitious because it goes up as high as 6.5. Now, 5 is considered hypersonic, and the only thing that's ever gotten up there is manned is an X-15. So I have a feeling they might have taken this Mach meter from the F-15. And also look down here, you see that red thing that says RSO ejected? And I thought, what was really trying to tell the pilot, the guy in back bailed out? It turns out, yes, that's exactly what it's for, because the pilot has no way to know. And in the RSOC, this is really cool. They have a button that says the pilot ejected. So, okay, so what's this plane doing up there this whole time? Well, all it's doing is taking pictures. That's its only job. And this is the camera that it used. This is called an optical bar camera. It holds 10,500 feet of film. It's got a bunch of rotating lenses. The pictures are taken through a slit. And this was used by Apollo 17 to map the surface of the moon. Pretty cool camera. This is just a diagram of the RSO's control of the camera. Turns out he can't see anything. He doesn't know what the camera is seeing. He has to rely on navigation and positioning to tilt the camera the right way and just sort of hope for the best. He has very little view. He can look up, and that's about it. And it also used an astro-inertial navigation system. Now, you guys all know what the zone of confusion is around a VOR or something. You know, it's when you're above it, it's the width where you really can't rely on it much. Well, at 85,000 feet, the zone of confusion is gigantic. And so using conventional navigation means doesn't really work very well. So this thing has a star map built into it, and it can see stars during the day, and it fixates on 2 stars it knows and gives you a fairly good position. And then it's got a traditional inertial navigation system, not ring laser gyro, because I don't think they had those in those days. But that's how this thing got around. And once in a while it wouldn't work, and they'd find themselves in somebody else's airspace. They've incurred into Mexico once doing that. We talk about inventing everything. Even the tires had to be invented. They're made of powdered aluminum, pressurized over 400 PSI, and they're only good for 15 full stop landings. Today's dollars, $23,000 a pop. So tires were pretty expensive. So this is an overhead view of the cockpit. This is a really complex plane. It's very difficult to fly, and worse, it is notoriously unreliable. it turns out that every time this plane flew on a mission, it took an average of a week to get it ready for the the next flight. Panels would delaminate, parts would get broken, rivets are popping out all over the place, and it wasn't unusual for it to take 1 or 2 months to get the plane flying again. So they built 32 of these. 12 of them were lost, none of them in combat. This plane was shot at 4,000 times and nothing ever hit it. But brake failures were a big deal when they were first testing brakes, because the brakes would fail, they'd burn, the gear would collapse and pancake the plane in, and they lost 2 of them that way. Instrument failures, I already told you about the high Mach breakup with Bill Weaver, and it once collided with its tank. So they first decommissioned it in 1990 because of budget cuts. Very expensive plane to maintain. All the parts were unique. All the crews had to be specially trained. There was really no cross training. So it took a lot to maintain this plane. And the missiles were getting better. And they started to worry, this thing's going to get shot down one of these days. And so they needed to do something about it. And the other thing that happened is this thing. This is a KH-111 surveillance satellite. Carries a lot of fuel, can maneuver around, reposition itself to almost any place on Earth. It takes a pretty good picture. This is an airfield in Iraq taken by a KH-111 in low Earth orbit. That's a pretty good shot. Now, of course, it can't shoot through clouds, but neither could the SR-71 because it was flying above the weather. So, where can you see one of these things? Well, they're all over the place. They're all in museums, and in California, you can see them in these places, and you confirmed to me that where's this 9? She told me, yes, that the plane is inside now, because I couldn't see it driving by the other day. The first 3 are the A-12. But this is kind of interesting. Anybody ever been to this little Santa Rosa Air Museum, Charles Schultz Airport?
Yep.
You been there? It's a cool little place. You know, they got an outdoor thing. I went there once during an athletic event and it was closed, but a docent happened to be there and he said, yeah, come in and have a look around. So I looked around and I was just amazed. The upper left is a spike inlet from an SR-71. That's the front end of an A-12, and they had a regular drone just sitting right there on the ground, which was kind of cool, worth visiting. So that's it. That's everything I know about the SR-71. And if you have any questions, yes, sir.
What aircraft replaced the SR-71?
No aircraft. It was the KH-11 satellites. Nothing could come close to this thing.
What's your background?
My background? I was in the technology world for a really long time. For the last 20 years, I've been a writer. That's as impressive as I can make it. Yes, yes, sir. Yeah, they were. They were a little on the rudimentary side, but yes, they had it. It was mostly teaching how the instruments work rather than the handling characteristics, but they did unstarts and starts and things like that. Yeah, sir.
Local trivia. Bob Gilliland, first pilot, he did the first flight on the SR-71. He lived here in Palm Desert. He passed away a few years ago in Acre. His son was still a lawyer in town.
I knew Bob Gilliland flew the first one. I didn't know he was here. Wow, really cool.
Pat Halloran made anything.
Pat
Halloran.
Halloran, no.
He was operational Air Force pilot by the SR-71.
Oh, no kidding.
For 8 years, and then went to the SR-71.
Wow.
He retired as a major general, and he was the wing commander at Beale of that reconnaissance wing that had the SR.
Yeah, Beale was the center for all of those things, right? Oh, good piece of information. Larry.
There was one on display at Eagle, Oregon, the Air Museum, sits underneath the wing of the Spruce Goose.
A sight to see. Anything else? Yes, sir. They were fighter pilots. And I imagine that they put them through a lot of, astronaut type training, except in the plane first flew in '64, which was just, a couple of years after they selected the astronauts. But some of these guys were astronaut candidates. Yeah. Anything else? Yes, sir.
See the cockpit straight on.
Yeah.
We had another picture where there was another cockpit looking forward higher above on just one model. What was that?
The only thing I can think of is that there was once something called an SR-71C. An SR-71 and an A-12 cracked up in an accident. They kind of glued the two pieces together, the fore and the aft of one and the other, and put that together, and one sat up a little higher. That might be it. That's possible.
Around for the POWs in Hanoi, they flew over Hanoi at supersonic speed, noise and everything else.
Oh.
And all the guys in the POWs were, yeah.
Oh, wow, I didn't know that. That's a good story. Okay, that's it? Yes,
I was at a big conference, pilots spoke, this fuller coffee table book. He actually took photos. The commanding officer kind of winked at it. Yes. Are you aware of such a book?
no, I've never heard of that. It sounds good. I'm gonna look it up. I
Steve,
appreciate it.
Steve, was it called Sled Driver?
That sounds.
Sled Driver's by one of the drivers.
Anybody ever see this thing fly? It's something to behold, isn't it? It's absolutely amazing. I saw it at Wainini. Yes. Hell of a plane. Okay, anything else? Yes, sir. Yeah. Oh, yeah, Larry, you've been in that. I mean, my brother-in-law's been in that, yeah. Oh, yeah.
Yeah.
Yes, sir.
It was my understanding that when the SR-71 took off, its climb rate was so rapid that they didn't pop the departure, they went to the tower right center.
I had not heard that, but I believe it. I believe it, yeah. Oh, yes, sir.
Any incidents of UFO sightings while these pilots were flying up that
None that were publicly reported.
good answer?
I don't know. I really have no idea. It would have, the RSO, he had a porthole above his head, which is where the astro-inertial navigation system went through. And so he's looking around there all the time, but I've not heard of it. I mean, they were the UFO when you get right down to it.
Aurora.
Yes, sir.
But I was, I flew with FedEx and I was flying from Memphis to San Francisco. And, the sun hadn't really come up yet, but you could see the skies starting to light up. And we did see one, it was, must have been going up off of March. And from the time we saw Yosemite, because we asked their traffic control permit for it was. By the time we passed over Yosemite, he had gone probably the whole length of California to be off.
And the plane's moving at a mile every 2 seconds. And one of the reasons it's hard to shoot down is by the time you figure out that there's something up there, and gee, maybe I ought to try to shoot this down, it's already 20 miles. So it made it tough. Okay, is that it? All right, well, thanks a lot for your attention.